Hello everyone. Today I'm going to discuss about my third project, that was retail analytics for store optimization and demand forecasting. So yeah, like the project has been divided into some components. So these are the components, basically anomaly detection, time-based anomaly detection, and customer segmentation and market basket analysis, demand forecasting. We have to also analyze the impact of external factors, personalization, strategy, segment quality evaluation, and real world application and strategy formulation. So here is the data set. Data set is like there are they have provided three data sets, three different data set, stores, features, and the departments. So these are the this is the features components. Store date, temperature, fuel price, and markdown 1 to 5. This is basically signifying the anomalized data related to promotional markdown. Markdown data is only available after November 2011. Or I forgot to mention that data set is all about related to 2010 to 2012 sales data. And this markdown is not available for all stores in the all the time. So there is set several missing values. This CPI is the consumer price index. Unemployment, the employment rate, it is signifying, and is holiday, whether the week is a special holiday or week. That is it is signifying. And sales data is we already I told, like, which covers 2010 February from 12 November. And so these are the features, these are the things. Stores sales comprises of stores, department, date, and weekly sales, and is holiday. So the task is we have to predict the department wise sales for each stores for the following year. And also you have to model the effect of markdown on holiday weeks. We have to provide recommended action based on the insights with prioritization placed on largest business impact. Also, we have to create one model so that we can predict the future sales also for the future years, like the data comprises of 2010 to 12 sales data, so that we can predict the 2013 sales data also as well. So these are the required libraries that I have imported before starting up with the project. So after that, I have imported the data sets from my Google Drive. So this is the first view of the data set. You can see all the columns, and these are the shapes of the data set. So the features 8190 rows and 12 columns are there. So sales data 42,000 4,21,570 rows and 5 columns are there. So let's start with the exploratory data analysis. First of all, as they have provided three different data sets, so we have to merge all the data sets based on the common columns. So first of all, we have merged the sales and the features dataset. Like we have opted for left join because we know the sales has more rows because it is a dimension table. So we have used the left join, and based on the stores date and is holiday, we have merged it. After that, the using that merged data, we have merged with the stores. Again, we have like used the left join. We have joined the DF with the stores based on the store column. So after joining, this is the first view of the dataset. You can see all the columns are present. So this is the statistics, descriptive statistics of the dataset. These things are like minimum 75 or 25% values and count of all the features, all the numerical features basically. So after that, I printed the ISNAL and some summary. So you can see, like for markdown, there are several NaN values, like several missing values. For other category, other features, there are like 0 missing values are present. So all features are okay only except this markdown category, markdown features. So these are the info about the data set. All the most of the features are basically float data type, and some are object and int. So after that, we have segregated the like object data set, object data types, and the numerical types. So you can see, like the stores, department, and the is holiday and type. This should belongs to the categorical column. So we have separated these things, as you can see. After that, we have converted these things to object because like stores and department was in int before it. So we have converted it to object, as like it's not creating any sense in the integer type. So we have converted it. So like now this is the data type after conversion. So now you can see all the numerical columns over here and all the categorical columns over here. So now we have we did the feature engineering, like we have extracted day, like first of all we have converted the date to date time, and after that we have like extracted month, week, and year from the date, and also we have converted the weekly sales to the log sales, so that it would be like easy to analyze with that thing. So this is the view of the data set after converting, after doing all the feature engineering things. You can see the log sales over here and the type encoding. These things means we have encoded by using label encoder. We have like converted the type to 0 and 1. So this thing. And this is the graphical insight. You can see over here, just a minute. Yeah, this is the graphical insight. So I have marked the peaks of the sales time based on the week. Like we have aggregated based on the week, and after that we have like plotted it and highlighted the peaks. Basically, you can see like based on the 2010, the peak is occurring on the month of October, and based on the 2011, the September, there is a peak, and for 12 end, there is a peak on October. So you can see I have added all the insights as well based on the chart. Based on chart, after that, I have checked the sum of weekly sales per year. Per year we have checked also. Look, we can see here like for 2011, there is most of the sales happened. After that, this is the month-wise sales. So I have aggregated based on month, and this is the visualization for that. And we can see for October the most of the sales happened. So October is the month when the most of the sales has been happening. So this is a sales trend by time. So on the 2010 October 12, the highest sales happened, and this is the graph for that. Like I have plotted the top 5 date where the highest sales happened. After that, we have analyzed the unemployment rate across time. So you can see from the 2010 to 13, the unemployment decreases. It's going down. It's going downward. So we can say the year by year, the unemployment has been decreased. And also we have checked the trend in average CPI across time. CPI basically it's indicating the consumer price index. So it is basically the measures of the average change over time in the price paid for a basket of consumer goods and services. Higher CPI indicates higher inflation. So we can see year by year the inflation rate is high. So CPI is also high. So you can see by year and year it is increasing. So we have we saw the trend in average fuel price and temperature as well. So fuel price is also the same thing. Like by year and year it is increasing. And for temperature, it is not there is any not there in not any trend. Based on the year and month, it is going up and going down. So the temperature data shows a seasonal pattern, basically with a peak during summer month and the dips during winter, like that. So no clear upward or downward trends observed in the temperature as well. So after that, we have analyzed the stores based on the highest revenue. So the store type A generated highest revenue based on the other stores. So these things, and after that we have analyzed the departments with high sales. So we saw that department number 92 has the highest sales, like they have generated most number of the most revenue as compared to other departments. So after that, we have visualized, we have by using heat map, we have checked the correlation between all the features. So we can see there is a weekly correlation of most all the features. Most of the features are weekly correlated. We can see weekly correlation of weekly sales with other parameters like CPI and unemployment. You can see CPI and unemployment, there is a negative correlation. You can see minus 0.3. And for others also, fuel price versus unemployment also, it's negative correlation only. Yeah, so all the features like except this employment and the temperature is little bit a positive correlation, and size and fuel price also there is some little bit correlation. Size and weekly sales also there is a little bit correlation. So that's all. So after that we have moved forward for the data preprocessing and feature engineering, so that like we can move forward and check all the anomalies, and after that we can go forward for the model building and those activities. So we have inspected data with the same step. I have I did again, like I have merged the data and I have created a combined data. So this is the state this is the shape of the combined data. Created a copy for it for the safety purpose, and check for the null values. We can see markdown there are a lot of null values are present, and check for duplicate values also. We can see there are like 0 duplications. So this is the thing. These are the like info of the thing, and we have converted the date into the like in this format: date, month, and year. And this is the statistics, like descriptive statistics summary for the all the numerical columns, and this is like a statistic summary for the object columns. uh, So after that we have we gone forward for the data preprocessing and anomaly detection. So the thing is that key, first of all we have to handle the missing values, and after that, as the sales values are, the figure is bit big, so we have to normalize it. We have to use min max scaling to sales value in the to like make all the values in the same range, so that model can perform well and model can train well with the data. And after that, to handle the skewness, we have to check for skewness. If there is any skewed features at present, then we have to do the square root transformation also. After that, we have to check the anomalies based on the z-score method. Also, we can see by using KD violin style plots to visualize the distribution of markdown variables for additional insights. So let's see. Let's do all the things. So this is the KD plot for markdown features. You can see there is like these are the right skewed basically. So this is the histogram basic visualization for markdown features. So we can it's clearly visible. Those are like right skewed. So this is the box plot visualization for all the markdown things. Oh, there are outliers are also present. So let's clean the data before doing the anomaly detection and handling. So these are the all I have taken all the markdown columns, and I have filled the all the missing values by using median technique. So after that, we have again checked the like null values. So after like handling the null values, we can see like all the like fulfilled, all null values has been fulfilled. So with the median. So after like fulfilling it, we can see the plot. It's a bit good now. It's looking good now. And so after that, we already discussed like we have to normalize the sales data as well. So we have used the min-max scaling to like scale it in the proper format. So normalized, this is the normalized weekly sales. The minimum thing is 0 and the maximum 1. So all the values are coming between 0 and 1. We scaled it. After that, like we will apply square root transformation to handle the skewness. As we already saw, all the distribution are rightly skewed, all the features that are rightly skewed. So this is this thing, like I have like applied the square root transformation. After applying square root transformation, and this is the weekly sales, and this is the weekly sales normalized after normalizing it, and this is the sales square root after like root square like transformation. uh, you can see the sales data is now looking good. It's near to its normalized now. So now after that, we have compared the weekly sales distribution before and after square root transformation. So this is the before thing, and this is the after thing. You can easily see like the graph, the feature has been changed. A lot of change happened. So after that, we moved forward for the anomaly detection in the sales data. So here we have used the threshold thing. Like we already know, like whatever data points are like residing uh, far behind the 3 standard deviation of the mean. So those points we can consider as the anomaly. So the same thing I have applied here. So these are the this is the anomaly report. This is the mean value, standard deviation, and this is the threshold. Basically, the values which are greater than 0.3776, we have considered those values as an anomaly. So the as per the thing, the percentage of the anomalies are 1.46%. So these are the count of the anomaly 6155. So this is the view of the anomaly data. You can see I have filtered a anomaly equals to 1. So these are the anomalies. So the count is like 6155 anomalies are present, and the good data is 41454, like 4 lakh 15,415. So this is the distribution of the anomalies. You can see this is the anomalies like for weekly sales anomaly detection. So 0, like these are the non-anomaly values, and only 6155 values are anomaly. So this is the thing. So like after that we have plotted like list of features to compare with the. So after that we have checked like what are the features basically causing for the anomalies in the weekly sales. So we have compared basically all the features with the weekly sales so that we can get like which feature is more contributing towards the anomaly sales. So this is the thing. So we have added all the features in the features to compare, and we have checked like check with the mean thing, like if the anomalies with feature greater than equals to mean percentage, and anomalies with feature less than mean, then we have printed it. So in unemployment, like the anomalies when unemployed greater than mean is 42.18%. So 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 these are the like only 42% anomalies are present, like which is contributing towards anomaly. And we can see like for markdown there is very less anomalies are present. For size there is a lot of anomalies are present, 86%. So this is the insight, like for the store size is highly correlation with, there is high, like for store size it is highly correlated with anomalies, like 86.50 of anomalies occurred in the store larger than the average size. And CPI is also is a highly contributor because 52.95% anomalies are happened with when CPI was above average. So this is the thing. A low contributor are marked down 1 to 5, and moderate influence happened by fuel price, temperature, and unemployment. So this is the thing. So this is the weekly sales versus other features, like only the anomaly values. So these are the anomalies we can see. These things, these red dots are basically our anomalies. Unemployment wise weekly sales, I have plotted it so that we can visualize the data. This thing. So this is the sales data, sales rate versus weekly sales anomalies are highlighted. So you can see these are the anomalies, so that they have highlighted it. Department wise weekly sales for anomalies data. So so this is the anomalies data based on the department sales. You can see for 92 there are a lot of anomalies are there. Uh, and store wise weekly sales, this is the graph for store wise. You can see store number 14 is more contributing to the anomalies, holiday versus non-holiday weekly sales. So where you can see like is holiday equals to false, means on non-holiday days the most of the sales happened. So date like sudden spikes on sales or specific date suggested event driven anomalies such as holiday promotion or seasonal patterns. So we can see like for holiday versus non-holiday sales, like non-holiday there are 5599 anomalies and 556 anomalies are present in holiday. So over 90% of the sales anomalies occurred during non-holiday. That is bit awkward. Like this is bit surprising as like on holiday usually we used to see in the high peaks, but in this case like most of the anomalies are present in the non-holidays. So maybe there was sudden markdown implementation or local store events or promotion, or the inventory fluctuations or data inconsistency as well, or other external factors or non-seasonal factors also can be the reason for the surprising peak during the non-holidays. So this is the overall key takeaways. Store size and department categories play a major role in the anomalies behavior. Most anomalies occur outside holiday session, which challenges the assumption of a seasonal spike. Economical indicators like CPI and unemployment show partial correlation, but are not the sole causes. Anomaly detection should consider multiple contextual factors to ensure accurate analysis and forecasting. So after that, we have moved forward for the box plot analysis of features versus anomaly. So this is the thing, like this is the box plot for plot of markdown 1 versus anomaly. This is the figure. This is the for CPI. This is for stores. This is the unemployment. So we have already founded like potential causes of anomalies. So after that, we have handled the anomalies in weekly sales using the isolation forest. We have already checked by using 3 standard deviation and mean. After that, I have used the isolation forest to check to handle the anomalies. So you can see I have used the skewness and kurtosis. So skewness means the skewness is 3.26 and kurtosis is 21.49. It is bit high. We know like skewness greater than 1 can indicate the right skewed, and the kurtosis means the peak is towards top, means the peak is high in this case. So you can see by using isolation forest, anomaly region, we can see like most of the like these are the outlier region, and this is the anomaly scores. So this red boundary is basically the outlier region. So we can see for the skewness we got 3.26 and kurtosis 21.49. I already said like the skewness greater than 0 indicates a right skewed distribution. So the distribution is totally rightly skewed. Most weekly sales values are lower and with a long tail of higher sales on the right, and these high sales weekly could be due to the holidays promotion and store specific events. And high kurtosis means a leprocotic distribution. Kurtosis value significantly greater than 3 indicates a heavy tail or the sub peaks. This implies more extreme outliers than in a normal distribution. Sales values are tightly clustered around the data but with significant spikes. So as a conclusion, we can say the weekly sales data is not normally distributed. There are many anomalies and outliers likely caused by the special event or holiday or irregular promotions, store behavior. Those are the reasons for the sudden spike or the rightly secured data. So based on that, we can do a transformation like square root or log to reduce skewness, and we have to use a robust anomaly detection method, isolation forest or Z square or I square to remove those anomalies from the data, so that we can apply machine learning models and so that it can perform well, and handle outlier carefully to improve model performance insight. So this is the square root transformed cells. You can see this graph has been improved a lot after applying square root transformation. So here we have handle all the outliers. Like we have set a threshold 0.2, and based on that, like we have like difference. We have taken the difference between mean value and median value, and if the mean value minus median values is less than threshold, then we have to append those columns, and like those are the symmetric features, and if that is greater than threshold, then we can say those are the skewed features. So accordingly, these are the symmetric features, fuel price and unemployment, and others features are basically the skewed features. So after that, we have set an outlier boundary detection for skewed features using the IQR method. So we have described the IQR formula. We have described the lower bound and upper bound, and we have created a function. After that, we have removed the outliers for the weekly sales. So after cleaning it, this is the shape of the data set. We have 3,86,049 rows and 21 columns. After removing the outliers, this is the isolation forest visualization. We can see this outlier region is very less. It decreased now, so we can use it. So now we will drop all the temporary columns that we have created during outlier treatment. So these are the temporary columns we have created. So we will drop these columns so that we can proceed with the model building and those things. So after that, we have re-evaluated the anomalies in transform weekly sales. So after to check like the all outliers has gone or not. So this is the report. So percent of anomalies are now 0.0%, and last time we have already seen there are 1.46% anomalies were there. So after that, we move forward for the time-based anomaly detection. So the objective was how sales evolve over time, detect seasonal variation or holiday effects, apply time series analysis to evaluate stores and department performance, and identify anomalies in sales patterns. So we have applied rolling statistics for time based anomaly detection. So we have like sort the values based on date, and we have created a rolling window. Rolling window and the threshold factor. Based on threshold factor, we are detecting the anomalies. So this is the column that we are generating so that we can check the values are like anomaly or not. Sales anomaly is to true means the values are anomaly like that. And this is the graph for that. So these red dots are signifying the anomaly values in the sales data. And this is the rolling average for 30 weeks. You can see there are not like sudden spike. We have smooth out the data by using rolling average. So this is the data sales by date head with the weekly sales and the rolling total sales and the sales anomaly. This is the table, and now I have applied time series decomposition of weekly sales so that we can get an idea about the like trend, seasonal component and the residuals. So this is the trend, long-term trends, and this is the long-term. This is the overall data visualization, and this is the trend up downwards and upwards. And this is the seasonal variation. We can see by seeing the data, there is lot of seasonal variations are there, and this is the residual thing. This is the residual thing. So we have time. This is the time series decomposition things reflects the overall upward and downward thing. So after that, I have applied the exponentially weighted moving average for weekly sales. Uh, so this is the model like weekly sales. So we have used moving average thing. So this is the graph, and the same thing we can see like there are several anomalous data are present. So these are the red dots are signifying the anomalies. After that, we have moved forward for the customer segmentation analysis using PC and clustering. So the first step is to like aggregate the key performance metrics such as all the features by group by both stores and department. We are going to cluster it by using stores and department. After that, we have to normalize it like by using min-max scalar. We have to normalize the numerical features in the 0 to 1 range, and also we have to perform square root transformation to reduce the skewness and make the data to suitable for the clustering. After that, we will do dimensionality reduction with PCA. We'll create for store level and department level both. So that we can get like the dimensionality can be reduced, and while we can preserve the most of the variance of the data. So after that, we will apply the elbow method for optimal number of clusters, and after that, we will do segmentation quality evaluation based on CLOUD test scores. So let's proceed it. So first of all, these are the features, and so these are the like I have distributed symmetric features and the skewed distribution. So first of all, we have normalized it, and we did the square root transformation so that skewness can be reduced. And this is the plot of transformed and normalized features. You can see the data is looking good now, a bit good now. So this is the store wise clustering, the group by store based on all the features I did min. So the group by stores and aggregate and aggregated function by using this min. So this is the data after doing aggregation. So based on store, we can see all the sales, fuel and those things. So after that, we have applied PCA for dimensionality reduction. We selected 3 components while we explain large proportion of the variance. So this is the graph. You can see three components we can take from there. The graph is moving towards. So these 3 can explain the more of the variance. So you can see like these 3 components I have taken, like the original shape was 45.9. Now the transform shape is 45.3. Now we will apply K-means clustering so that we can get the cluster thing. So elbow method, we have applied the elbow method to get the number of clusters, optimal number of clusters. You can see this is the thing. This is the elbow method WCCS within cluster sum of square graph. to get the K value. After that, to get the segment quality evaluation, I use Silhouette scores. So this is the graph for that. This is the 2, this is for 3, this is for 4. We have to see for how many number of cluster we're getting higher Silhouette scores. So for like we can see, this is the result, 2 cluster 5092. For 4 cluster we're getting highest number of Silhouette scores. So we will consider 4 cluster. The same thing we have done, we have done for department wise clustering as well. So we are skipping the part, as I've done the same steps for the department also. So let's see the next part, like the other thing I did for the analysis. So so this is the cluster visualization, store segmentation based on like optimal number of clusters. So I have applied K-means. So this is the graph. We have created 4 clusters, and these are the centroids for all the clusters. This black cross is denoting the centroids. So the graph is like looking good. The K-means is able to show the perfect clustering thing. So this is the thing, and these are the PCA thing. I have extracted 3 PCA, 3 variants, like 3 core features, so that we can explain the most of the variants of the data. So we have categorically encoded the stored types. We have used one-hot on encoding to make it 0 and 1, and made the index as stores, and this is the data after like doing it. So this is that we have like combined type A, type B, type C after like encoded it. So we have like merged it with the main data. So this is the dummy data set. So we have this is the like final cluster data frame. This is the final cluster data frame. So so this is the, you can see, like for level 0 there are 13 stores, for level 1 there are 8 stores, for level 2 there are 14 stores, for 3 there are 9 stores. So this is the list for cluster, for all the clusters that we have created. These are the store lists, and we have also counted stores based on the cluster. So this is the like count of the stores based on the cluster. For cluster 2, there are number of stores are high, and this is the store level feature aggregation. So this is the thing, this is the data after aggregation. So we also did the merging the store level thing. So this is the mean weekly sales for each cluster. So we can see for the cluster for cluster 1, the highest weekly sales happened. So this is the graph. You can see cluster 1, the highest weekly sales happened. So mean consumer price index by cluster. So this is the, so for cluster 0, the consumer price index was high. Then this was the cluster wise mean store size. So for cluster 1, store size was high. Cluster 2, the store size is cluster 2, the yeah, for cluster 0, the store size is high actually. So this is the inferences that I already said to you. For the mean weekly sales, store 0 had the highest sales. No, sorry. Store 1 has the highest sales. For CPI, store 0 was the highest CPI. The same thing I did for the department as well. The same insight I have extracted from there. I have like created cluster for it. You can see here also this clustering is showing good. So this is the thing. Based on the Silhouette score, I have created the clusters. So the same thing I did, I have counted the department based on the cluster. We seen the weekly sales based on the cluster, also the CPI average, like fuel price, those things also I have analyzed. So this is the thing. We are skipping this part, as I already discussed for the stores. I have added insights as well based on the like report. These are the inferences. So after that, we have moved forward for the market basket analysis. So market basket analysis helps us to identify patterns in product purchasing behavior using transaction data. We can discover frequently bought together item sets, association rules to support production bundling and promotions. So we have used Apriori algorithm is a for that. It is a popular method used in association rule mining, especially in market basket analysis. So first of all, we have imported all the thing to like work with the like Apriori algorithm. After that, we have filtered the sales data by the relevant stores. So this is the thing. Filtered the stores data based on the filters the all the data based on the stores, all the relevant stores and list of the department number to analyze. So after that, we have prepared a transactional data for association rule mining. We already know like association rule mining can be applied on the transactional data. So we have created it. So we have created transactional data. This is the like we have used the group by we have grouped it by date and department based on stores and applied a list. This is the list. This is the transactional data. After that, we have applied the Apriori algorithm. So these are the association rules that we have generated by applying Apriori algorithm. So extracting and displaying association rules. These are the this is the rules we can generate. We got the support of 0.014 and confidence 0.0812. These are the all rules and their support and confidence and lift we got. So after that, we have structured the association rules in a data frame. So we have created a data frame based on the antecedent and consequence. So antecedents are basically which the item that brought together a consequence, like those are likely to be brought together with the antecedents. So these are the inferences and the descriptions regarding the market basket analysis. So per stores, weekly sales is basically weekly sales per stores and department date. We grouped it by department and stores. So this was the parameter. These were the parameter minimum support, minimum confidence, and those things. So Rule 1 has the confidence of 88.11 and support of 1.814. So department 29 is very likely to be bought when the majority of the other departments are purchased. Strong complementary. So this thing like that we have added for rule 3, rule 4, rule 5 as well. So these are the strategic recommendations. So cross merchandising place frequently associated departments is in 29, 30 and 34 closer in physical and digital layouts. Promotions like bundle offer involving higher confidence department pairs like 65 and 34, 35 and 1 to 45, and stock and restock associated department together to reduce stock outs. Use rule-based segmentation to design offers for customer buying key department sets. So the market basket analysis reveals strong association between the specific department, often involving large departments group like 1 to 45. The high lift and confidence of many rules suggest that robust and actionable relationships. This finding can support store layout planning as well as product bundling and personalized promotions to boost overall sales performance. So these are the cross-selling strategies based on the association rule mining. So these are the thing all the thing I have mentioned here. After that, I have moved forward for the demand forecasting. So these are the techniques I have used for the demand forecasting. We have used moving for averages, exponential smoothings, SARIMAX, profit by the profit I have not used, but I have mentioned it. We can use it, and we have used machine learning, random forest. Basically, XGBoost I have not used, and we can use in future. We can use deep learning, LSTM, and RNN also. So let's begin. We have like imported here all the necessary libraries to use SARIMA model. First of all, we have merged it and grouped by it by using the store and department. After that, we did the data preprocessing part, filled markdown with the median values. Those things I did. After that, I have created date as the index and clean the data and normalize the numerical feature. We normalize the numerical feature and divide the data to train and test. So this is the short term I have applied. After that, SARIMAX model, normal SARIMAX model with the standard parameters. So I got the MAC and RMAC of 10,768 and 12,559. So after that, this is the thing, and this is the plot of those thing autocorrelation and partial autocorrelation plot. So this is the thing, these are the outliers or anomaly thing. You can see these things. So after that, we to get the base SARIMA model using auto ARIMA, I have used auto ARIMA. So these are the parameters I have passed. And after that, I got like these are the parameters in the base model ARIMA with 101 and 10052 intercept parameters. So the same parameter I've used here, like I have used the same thing here, like train the SARIMAX model and got this plot, and this is the actual sales and the SARIMA forecast. This is the SARIMA forecast, and this is blue line is indicating the actual sales. And we got the accuracy of the mean absolute MAE of 5295 and RMSE of 9344. So it got reduced now. So after that, we did the long-term demand forecasting using a random forest regression. So for that, we have to drop the weekly sales from the extend Y trend. So we have feed the data on based on the extend Y trend and predicted it. So this is the thing I have predicted it, and this is the MAE and MSE value. MAE value we are getting as 1692 and 2934. So this value is indicating this there is the model is reading the data, maybe because of that we are getting less MAE. So this is the model forecast and actual. Since you can see the thing is it's like slightly same only. So let's mod like after that I have tuned the parameter using grid search CB. We have like passed different parameters so that we can get the best parameter to train the model. After that, by using grid search CV, we got the best parameters as well. So these are the best parameter. Max depth, it should be 10, max which is square root, and minimum sample equals to 1. Minimum sample split equals to 2, and n estimator equals to 200. The same thing I have applied here. And like this is the optimized MA and MSE. So I got ME about 8942 and RMSE over to 9231. So after that, I plotted it optimized like RF forecast and actual sales. Now this is looking good. Now it is predicting properly, I guess. So the optimized random forest model achieved the following performance. Like this is the result I got. So these metrics indicate notable improvement over the initial random forest model, where which had like RMC and MAU was low, because it suggests that the initial model was likely overfitted with or misconfigured. So that if we pass the unseen data with that model, it can predict like unknowing data. It can predict it can't predict it in a good way. Actually, that's why we have used the optimized random forecast. So after that, we seen for the feature importance, like lagged sales once contributed more towards the model, and the lagged sales too. After the temperature, CP, and fuel price. So after that, we have added a lagged and rolling average features. So this is the thing. Shift one means the lag one and lag two I have created based on shift by using shift one and two, and also we have created rolling average features. So after and again we have retrained the random forest model with enhanced features. So we got the MAE of 1387 and the RMSE of 2586. So this is the enhanced random forest forecast versus actual. So this is actually after enhancing the thing, this is the like good prediction, I would say. So this is the error distribution of SARIMA versus enhanced random forecast. We can see like for an enhanced random forecast, like the errors is bit low as compared to SARIMAX. So after that, we have like forecasted the sales of 2013. So before doing it, we have prepared the data. We have calculated the mean based on date. We have created group by date and calculated all the mean. So this is the data for to train the model. So after that, we have resampled the data based on weekly frequency and backfill the missing values. So this is the code for that. Fill method equals to backfill, and we have we taken the converted resample data based on week wise. So after that, we have calculated the seasonal, we have analyzed the seasonal decomposition. This is the weekly sales, and this is the trend component you can see, and this is the seasonal component. So we can see there are seasonal fluctuations are there, and residual component. This is the residuals. So after that, we have seen the correlation also. the same thing, like there is no correlation, there is no positive correlation. Only for few features there are very less positive correlations is there. So this is the weekly sales during holiday versus non-holiday weeks. This is the thing. So after that, we have forecasted using the Holt-Winters model. Like this is also called as triple exponential smoothing. Uh, the level baseline value, like level is indicating the baseline value, trend is long-term increase or decrease, seasonality repeating short-term circle. So these are the components. Like I have trend is exponential smoothing, the data is weekly sales. Though on the, like, first of all, we have trained the data based on the first 120 weeks, and trend was at, seasonal was at, these are the parameters, and we have predicted the forecast for first 34th week, 34 week, like forecast the next 34 week to complete 2012. We don't have the complete 2012 data and forecasted for next 34 weeks. So and also these are the actuals 120 to 154. So let's see, these are the sales values. And now we have, like, we are visualizing it. This blue line is actual sales, and the this yellow line is predicted. This is also okay, but not that good. So after that, this is the MAP calculation, 6.65% we are getting. And after that, I have optimized the whole winter forecasting with parameter tuning. So we have add weekly seasonality, seasonal periods equal to 52, additive trends and seasonal component, damp trend to control the exponential growth, and also we did box cost transformation for variance stabilization. So this is the thing I did. These are the parameter I passed. And after that, we have forecasted for 34 weeks, and we have, this is the data. So this is the, after that we are getting MAE and MAC, RMAC of this one, this much, and optimized. This is the optimized forecast versus actual. So this data is also, this model is also doing good, but not accurate actually, I would say. So this is my MAP calculation. MAP is reduced a bit. So now we have forecasted the 2013 weekly sales using Holt-Winters model by passing the full historical data. So here we have passed all the, like, exclude last two rows, exclude last two rows, rather than that we have passed all the rows to the model, and forecasted 56 weeks for 2013. So this is the sales data, 2013 sales data, weekly data. So this is the visualization of 2013 sales forecast using Holt-Winters model. So this is the actual data, and this is the sales forecast for 2013. You can see this is the sales forecast. So inference, these are the inference that we have extracted by plotting those things. So this is the external factors. So these are the factors that have contributed, the temperature and fuel price. Those are the external factors that are impacted a lot. Unemployment and CPI also. So here we have this, I added the insights as well. So we have here incorporated the external factors into forecasting model. So these are the percentage and counts and these things. So here we have forecasted weekly sales with external factors like CPI, temperature, and fuel price. So we have considered all three features over here, and these are the errors. Like the less error we are getting with RF with external factor errors, less errors we are getting. So this is the evaluation metric, like we got of MAE of 1702 and got RMSE of 2756. And here we have plotted the random forest forecast versus actual sales with external factors. So this is the random forest model. This is the plot, actual sales and this thing. So after that, we have extracted, we have we have added the real world application and strategy formulation, the seasonal forecasting, dynamic pricing, supply chain optimization, marketing strategy, store optimization. These things I have added. So now So these are the strategies I have added: filtering sales data to 10 department 1 to 5. Weekly sales trend by department. So we have extracted the weekly sales trend by for department 10. For department department 1 to 5 actually. These are the trend. So department 1, notable increase in April actually. So by seeing this, you can see for like blue is indicating 1. For 1, we can see in the month of this month the peak is high, like that we have extracted. So this is the causal impact interventions. We have like we simulated a marketing interventions and analyze its impact on sales. We basically induce a marketing campaign for department 4 during Q3 of 2012. Department 4 was selected due to its historically consistent sales pattern. We already seen like for department 4, sales maintain a consistent pattern with minimal fluctuations across the years, indicates steady demand and possibly of essential or household items. Steady 4 means you can see the sales pattern is very steady. So we have chosen the department 4, that's why. So we introduce a new column, marketing campaign, that flags the campaign period as active and the rest as inactive. The conditions applies only to department 4 and the date range is July 1st, 2012 to September 30th, 2012. So this is the condition and those things column I have added here. So this is the marketing campaign column. So simulating sales increase during marketing campaign. So we create a new column as new sales, which applied the uplift during the active campaign window. So here we have like added 1.45%, 1.45 into 1.5 to like weekly sales during the campaign campaign active period. So this is the marketing campaign inactive period new sales, and during the active period we have increased it to visualize the impact of marketing campaign on department 4. So this is the like visualization during this period. We have applied the marketing campaign. We have we updated the sales into 1.45 so that you are able to see the sudden spikes here. So for this those are part like this time we are getting the high spike. So this is the causal inference analysis using causal impact. So pre-intervention period was 2010 110 and 2012 629, and post-intervention period was 2012 79 to 2012 1026. The model will compare actual post-campaign sales with predicted sales, what would have happened without the campaign, allowing us to quantify the causal impact. So here is the the min date and max date that I have passed. So I have created an index, and so this is the marketing pre-period and the post-period, and between in middle of that, actually the marketing happened, and so that's why we have created a extra column, a campaign activation. So I have applied the causal impact over here on the data set and by passing the pre-period and post-period, and this is the summary that has generated here. This is the summary that has generated. So this is the thing, like here we are getting the spike. So this is the causal impact summary. A marketing campaign for department 4 during Q3, we obtain a summary of the intervention by passing the causal impact model. So this is the impact summary. So you can see like posterior inferences overview. So actual sales happened. This one is the average. Cumulative impact is this one. Rated sales was this one, and the cumulative impact was this one. So 95%. So this is the observation. So significant increase in sales. The marketing campaign led to a 29.94% increasing in weekly sales for department 4 during Q3 2012. And the posterior probability of a causal effect is 100%. The p-value is 0, indicating extremely strong statistical confidence that the increase was due to the campaign, and high return on investment potential. The cumulative uplift is in sales over the post-intervention period was approximately 247,735, showing the marketing campaign was highly effective. Like during that period, high sales happened. That's why we are getting return on investment too high. Confidence interval support effectiveness. Even at the lower bound of 95% confidence interval, the campaign still yielded a significant uplift in sales, 27%, confirming the robustness of the impact. So that's all about the project. Thank you.